Hi everyone, Miss Javner here to check in on our next notes here of continuing to learn about collision theory and how it affects the rate of a chemical reaction. So we learned about collision theory a couple days ago, and so I want you to take a moment to think about what three things are required for particles to successfully react with one another. All right, here they are. First thing is they have to collide. They have to collide with each other in space to be able to rearrange and combine with one another. Second, there must be proper orientation of colliding molecules. The molecules need to collide in the correct direction. Third, collisions must occur with enough energy, specifically enough energy to overcome the activation energy. So our standard for today is, our last standard of the unit, is I can describe how changing concentration, temperature, particle size, or surface area, or the addition of a catalyst affects the rate of a reaction. So here are the four factors that we're going to look at. So the first one is temperature or particle speed. So looking at how does the speed of particles affect the rate of a reaction. The second is concentration or the amount of particles. How does adding more particles affect the rate of a reaction? 3, surface area. So how many particles are exposed on the surface? And 4, catalyst. A catalyst is a substance that simply speeds up a reaction. So we will be exploring how it does that. So let's look at each of these factors in more detail. So the first factor is temperature. Increasing the temperature increases the average kinetic energy and speed of the particles. Particles will collide more frequently and more forcefully, resulting in more collisions. At a lower temperature here, the particles are moving slower based on the swoosh lines that I see. And they're going to have less forceful and less collisions happening here with the gray particles. Where over here, my particles are moving much faster. So therefore my particles are going to be more likely to collide if they're zooming around faster. And also the collisions that happen are going to happen more forcefully. Imagine kind of the idea if two people are walking and bump into each other very slowly versus two people are running at each other and collide very fast. It's a very different collision. So that's the first one, temperature. So the warmer temperature results in faster moving particles, and they're more likely to collide. And there's more likely that they will collide in the correct direction if they're moving. And the collisions are happening more often. The next factor is concentration, or the amount of particles. So increasing the number of particles will increase the number of collisions. That's what that says. So it will be more likely that a successful reaction and collision will occur. So here, low concentration, I don't have a lot of particles. I just have 4 red and 4 white. And so it's going to be harder for them to collide. But here, if I looks like more than double my concentration of each particle, they're going to be more likely to collide in the correct direction with the correct amount of energy. So therefore, a higher concentration will increase the rate of a chemical reaction. The third factor is surface area. Increasing the surface area will increase the number of particles that are able to collide and create that successful collision. So if you think about what surface area means in terms of math, this image over here on the left has a low surface area. There's less opportunities for the particles to collide because some particles are hidden on the inside. They're not exposed on the surface, so they're not going to be able to react. Over here, though, if you were to break this substance down into its more individual pieces, now I have a higher surface area. There are more opportunities for those collisions to happen because more particles are exposed. The last factor is adding a catalyst. Adding a catalyst is another substance. A catalyst is not actually involved in the chemical reaction. It is not a reactant or a product. It simply makes the reaction easier to occur by lowering the activation energy. It helps the particles collide. So on this graph here that we've seen before a couple times, reactants to products, typically you have to overcome that activation energy before it can turn it into a product. What a catalyst does is it simply lowers that barrier. It makes it easier for the reaction to occur. It doesn't change anything about the reactants or the products. It simply provides another path for the reaction to occur. Here's another image. So it's like the idea of the person pushing the rock over the hill. The catalyst lowers the size of the hill, making it easier, once again, for the reaction to occur. It's easier to push a ball over a small hill than a large hill. So with a catalyst, it makes it easier for the reaction to occur. The way it actually does this is providing a space for the particles to meet, making it easier for them to collide and react. So over here, if I'm trying to get the purple particle and the orange particle to react with each other, what the catalyst does, the catalyst is this green particle. The catalyst has space available. The orange particle comes in, the purple particle comes in, and now they are right next to each other, and it allows them to meet and find each other, and now they can pair up and move on as a product together. Over here, the same thing. If I'm trying to get these two red particles to separate, a catalyst again provides that space for the particles to come in, and then it has them separate, and then my particles are able to leave separated. So a catalyst simply makes it easier for them to meet, collide, and for the reaction to occur. So what you're going to be doing today is completing some at-home labs. You can either watch my videos or you can complete the experiments at home to learn about each of these 4 things. You will be completing a lab handout for this experiment. So temperature, you're going to look at Alka-Seltzer in different temperatures of water. Concentration, you're going to be placing nails in vinegar. Surface area, you're going to be looking at a solid versus a crushed Tums tablet in vinegar. And catalase is we're going to be finding the catalyst for hydrogen peroxide. The last thing I want to point out here is this video. You saw a little bit of already. It really does a great job giving that analogy of trying to find a date. And so it's kind of funny, kind of cute for how to speed up a chemical reaction in terms of getting a date to the dance. So check this out if you want kind of a fun analogy here for how to speed up a chemical reaction. So have a great day doing your labs, everyone.